This is a weekly summary of interesting news that is relevant for my distributed systems lecture at the Eastern University of Applied Sciences in Switzerland. My name is Thomas Bocek, and today I have 5 topics. The first topic is about CodeQL leaked, which is the following article here. It's about the public secret exposure that led to a supply chain attack on GitHub CodeQL. A supply chain attack on GitHub CodeQL was possible due to a publicly exposed secret, and the secret was only valid for a very short time, about 1 second, but this was enough for attacking and exploiting it. The issue started when a security researcher found a GitHub token in a GitHub Action workflow artifact. The token had a full write permission and could be used to create branches, tags, and upload release artifacts, but only for a very short time. The researchers proved that it wasn't just a theory by creating a script that could download the artifact, extract the token, and use it to make changes to the repository before it expired in that short time frame. And what makes this attack dangerous is how CodeQL works. When user enables CodeQL in their repositories, it runs actions from the GitHub CodeQL action repository using a specific tag. An attacker could replace this tag with their own malicious code, which would then run on every repository using CodeQL. This could lead to source code theft from private repositories, stealing credentials and secrets, running code on internal systems, and compromising GitHub Actions workflow. The vulnerability was fixed quickly by GitHub, who responded within hours of being notified and disabled the workflow that was exposing the secret. So be aware of supply chain attacks and run your code in containers, ideally, to limit the impact of such attacks and isolate potentially harmful code. The next topic involves GitHub Actions as well. It's the following article here. Whose code am I running on GitHub Actions? Following the GitHub Actions change file attack that I talked about in lecture 6, where malicious code was added to leak secrets to build logs, there's a growing concern about mutable references in GitHub Actions workflow. And when you use tags like, for example, add v2 here, this one in your workflow, you're actually using a mutable git tag. If someone changes where that tag points, your workflow will run different code next time. Using a git commit ID instead gives you an immutable reference that will always run the same code. This is what the author argues here. The trade-offs is between convenience and security. Tags are easier to read and compare, but commit IDs provide better security against unexpected code changes. To check which actions you're using, you can run a simple shell script to find all workflows and create a list of actions they reference. This helps you evaluate the risk based on who maintains each action. Actions from large organizations like GitHub are generally safer than those from individual developers. In some cases, it's better to write your own script rather than rely on someone else's action, especially if you only need a small part of the functionality. So again, be aware of supply chain attacks and run your code in containers to limit the impact of such attacks and try to isolate these potential harmful code. However, I want to mention that these git commit IDs that the author proposes only helps if you review the code yourself. And if you see that the functionality is small, I agree with the author, then write your own scripts. The third article is the following article here. It is In German, it's about US cloud providers and the recent political development. This is an interview, and in this interview, Dutch computer scientists and intelligence expert warns that European governments need to urgently exit American cloud services. He explains that US surveillance laws like FISA and the Cloud Act apply extraterritorially, requiring US companies to hand over data to American authorities, regardless of where it's stored. Despite Microsoft's promise about EU data boundary, the researcher points out that these contain legal loopholes and Microsoft remains bound by US laws. He also believes the data transfer agreement between the EU and US will soon collapse because the US is no longer upholding its side of the privacy protection. He warns that with AI capabilities, US authorities can now more easily process and analyze European politicians' email stored on Microsoft servers. As a solution, he suggests creating a sovereign technology agency in Europe that would fund thousands of programmers for 10 years to build European government cloud services. I'm not sure if it's a good idea because first we would start by debating which tech stack we should choose and which color we should paint this cloud service. The next article is about HTTP 3. It's the following article here. And I mentioned in lecture 6 that many tools do not use HTTP 3 yet, and this article shows why. The DNS resource record provides service metadata about target host names. This is currently available as an experimental feature in curl. HTTPS resource record includes several important features. It provides encrypted client hello config data, which helps encrypt the server name indication field in TLS handshakes to prevent revealing which site a client is connecting to. It offers an application layer protocol negotiation list showing which HTTP version a server supports, which is quite important for HTTP 3. With HTTPS resource record, clients can learn about HTTP 3 support in the first connection, which significantly speeds up the upgrade process. Adding HTTPS resource record support to existing TCP client like curl is challenging because the standard POSIX function getAtterInfo doesn't support it, and this is why it's not that easy, and curl came up with 3 methods on how to get those records as they're not available via getAtterInfo. So we're getting slowly towards HTTP 3, and hopefully we will have those resource records exposed in getAtterInfo by default soon. The last topic, it's the following article here, is about self-hosting. This blog post summarizes useful software for self-hosting setups, focusing on solutions that aren't as widespread but deserve attention. According to the author tested those projects and provides his experience. For container runtimes, Docker remains the standard choice with extensive documentation that makes it accessible even to less technical users. Podman is gaining attention for its rootless architecture and Docker compatibility, with the possibility to run without daemon. Kubernetes, while often seen as overkill for home use, can be a rewarding challenge for those wanting to learn enterprise-level tools. To manage containers through a web interface, Portainer stands out as the most stable option, working well with Docker, Kubernetes, and Podman. Then docge is a newer alternative created by the developer of Uptime Kuma with simplicity in mind, though not yet as mature as Portainer. For accessing self-hosted applications remotely, there are two main approaches: exposing them to the internet or using a VPN. And here, Pangolin combines these by integrating a VPN and reverse proxy in one package, functioning like a self-hosted version of Cloudflare. Nginx Proxy Manager offers a user-friendly interface for creating proxies, but the author claims it can be buggy. Caddy provides a simpler file-based approach without a web interface, and NetBird works similarly to Tailscale, managing a WireGuard network with reduced complexity. And for monitoring, Uptime Kuma offers straightforward service monitoring with notifications through various channels, including Gotify, a notification management system that can be installed on phones. Finding additional application is made easier. Here he mentioned awesome self-hosted, self-host, and awesome Docker Compose. Well, I also self-host, and the only thing I'm running that also the author mentions here is Docker, but what looks interesting to me here is Gotify, which I'll take a look at. See you next week.